Let's talk about other happiness things. So GDP, right? So one of the problems we have perhaps with quantifying how well society is going is that money is easier to measure. So we tend to have fronted that. So GDP, this is Robert Kennedy, this is a long time ago, right? Measures everything except that which makes life worthwhile. It's like having traffic and measuring throughput, like that thing we had the other day, right? Like this is the best one. It is by some number, but it's not if you're a beaver that's trying to cross the road, right? That's not a good thing. Could tell us everything about America except anyway. So it's, yeah, of course, it's rhetorical, but the point is, it's not just a great thing to measure. I know I've had this in other places, but this is part of the inspiration, right? Measure is to know. If you can't measure it, you can't improve it. And so that's a really deep issue. And Kelvin, very famous, he would have been very surprised, of course, by quantum and chaos later on. Things like this, yeah. So, yeah, we cherry pick people's lines. Also true. Right, so just to give some motivation for why you would want, I mean, obviously in science we have these measuring instruments everywhere that are very important, but just to look back in history, it could be a bit surprising for some of the things we're so used to. So clocks, for example, we struggled with building really accurate clocks. It's really only in the 1700s that we made little machines that we could take with us that would keep time. And this is really important if you're floating around in a boat trying to find other places to pretend it's yours with some dubious legal maneuvers. So I don't know if you know, Australia's was declared terra nullius, right? So that was some deft, marine lawyer activity, and it was the threshold was because the native Australians did not till the land. So, right? So they're like, this is no one's land, terra nullius. So it's not a conquest, it's just like England or the Dutch, or actually, yeah. The Dutch were there first, actually. It was New Holland, right, for a while. Van Diemen's Land for Tasmania. New Zealand, of course, is still New Zealand. But there were various Dutch people who walked into the middle of Australia and stopped walking. And then they stopped exploring. But didn't work out. Yeah, Manhattan, right? Yeah, Dutch, yeah. They sold it all. Okay, so measuring things. So this was a big deal, right? And what I'm saying is when you're floating around on a boat, you really need something to measure things well, and that's what this right up here was. This book did very well for itself at the time, for a science book, but it's about, there was a great, a big prize offered with it in England for someone who could, for the invention of a clock or a system of keeping time. So a lot of people were working with stars, right? They thought they could do it with stars. That helps you with latitude, but not, because you've got the North Star, you could figure it out, and so on. But the longitude was really difficult, and so they kept crashing into things and getting lost and eaten by sea monsters. At least that's what the pictures of the time suggest. But it was, it ultimately was, it wasn't what everyone was heading towards, but the Harrison and then his son figured out this way of making a mechanical clock that would just keep time. You couldn't put a pendulum clock on a boat, so it's just a disaster. But if you look back, it's kind of funny. I think hourglasses, apparently even in the 1300s, you'd think we might have made them. It's somewhat hard to make a nice hourglass, I suppose. Sundials are 3,500 years old, and we've used those for a long time. So this just took us a long time to build these things. All right. I know I've probably been here before with these words, but I just want to set it back in here as well. So Lord Kelvin, who obviously wasn't right about everything, said actually this atom story could work out. And I think it's going to be pulsars. I think that's how we're going to, because pulsars are they're pretty big. They tend not to explode, right? They tend to be pretty stable things, and they make for really good clocks. I think we may tie, in the future. All right, so we're pretty happy with clocks working, and of course, if you have GPS things, then it's all being synchronized by this absurd thing that we have, right, with satellites, and we're all very trusting. The GPS story apparently is because of Sputnik, right? So Sputnik goes up, and you've got a bunch of Americans like very worried about the situation, and they decide that, so they figure out how they can find out where it is, and then someone realizes a few weeks later that you could do the opposite, right? So if you have 3 positions on the ground, you could figure out where it was, triangulate it. But if you had 3 satellites, you could, and they were passing information, you could triangulate yourself. So Sputnik kind of spurred on the origin of GPS. So this is, the main book here is Inventing Temperature, and it's a, and you have to read this, but it's looking back in time to see how the thermometer came into existence, or ability to measure temperature. And so Galileo apparently, right, I mean, of course there's records, I'm sure someone tried in 4,000 years ago, was probably put in a boat and sent off to sea for being bad. So 1592 wasn't very good, right? It was a bad instrument, makes sense. But I think this is the important thing, right? So the idea is subtle and complex is all the manifestations of changes in temperature could be measured and quantified on a single scale. People thought you couldn't do it, right? This is just something we will not do, right? We can measure distance accurately, right? And I can make a stick and give it to you, and famously for a long time, right, we've had the kilogram thing, which is just this kilogram in Paris, and you go and copy that one with another one, and that's our reference. We're trying to evolve past that because that's not a good plan, right? I know I talked about it. Radiolab had this piece on it where, much to the dismay of everyone, it had gone down by 1 grain of sand in weight, and so this is not good for our measuring system. It's because they cleaned it. Because all the copies they'd made all weighed the same, but this one now weighed something different. So this idea, right, so feverish heat, prickly heat, but we have these very sort of personal views of heat as well. So how could you actually just have this little instrument that would measure something? We know, things get warmer, of course, we have the sense that there is something going on, but there's a subjective element that people thought really mattered and would make it impossible to actually build this instrument. But what happens is, it does get built, and it takes until the 1800s. What else is there? And so this is sort of the key thing in here, is that the thermodynamics takes off, right? The science takes off completely once you actually have real thermometers, yeah? So it's the middle of the 18th century, so 1700s, and then you've got that before the theory, and then of course that it makes it possible. It absolutely makes it possible. I mean, some of this, I guess it sounds obvious, but I don't know. If you ask people in general, when did we first have thermometers? I think the idea that people were really against them, against the concept, like this is a quixotic, just don't do it. Like, you're not going to make something certainly on this, what we have now, where we have this great, Kelvin, we just have this scale. It's incredible.